All right, so our second lesson deals with work and word problems. A lot of people panic because they're word problems, but if you can read, you can do them. So if you can do a job in 6 hours, how much of the job can you finish in 3 hours? What portion of the job can you get finished? So to find that, we take the time spent and we divide it by the time needed to complete the job. So the time we've spent is the 3 hours, and the whole job takes 6 hours to complete. So in 3 hours, I would get 1/2 of the job done because 3 over 6 reduces to 1/2. In 6 hours, if I spend 6 hours on a 6-hour job, I should get one whole job done. So that should be the entire job. And then in 2 hours, if I spend 2 hours of the 6 hours required, I should be 1/3 of the way finished. So it's fairly straightforward if you just have one person working. If you're the only person working on the job, take the time you spent, divide it by the entire time it takes you to do the job, and that's going to be the portion that you've got finished. But when we add in a second person, we have to calculate the work done by person number 1 plus the work done by person number 2, and we always want that to be the whole job. So the way we're actually going to use is right here. So the time that's been spent, or your together time, divided by the time it takes person number 1 to complete the whole job themselves. So if Dylan and I are working on cleaning the entire Excel center, it might take him 4 hours and it might take me 5. So he works faster than I do, but if we work together, it should take us less time than Dylan can do it on his own because he's the fastest person. So question down here says, if Ryan can fill an order in 10 minutes working alone and Crystal can fill it in 10 minutes working alone, how long would it take them to do the job together? So for this, we leave the T's on top, the together time on top, because that's what we want to know. One of the fraction we need to plug in Ryan's alone time, and one of them we need to plug in Crystal's alone time, and then we want this 1 here because we want them to do an entire job. So we want them to finish the job completely. So here we know Ryan's alone time was 10 minutes. Crystal's alone time happened to also be 10 minutes, and we still want it to equal the entire job. So here I want to eliminate my denominators. To eliminate denominators, you just multiply by your least common denominator. So I'm going to multiply every single term by 10. When I do that, these 10s cancel, these 10s cancel. So I'm left with t plus t equals 1 times 10, which is 10. My room. T plus t is 2t. So 2t equals 10. Beside it, divide it. Together, it should take them 5 minutes. Now, I know a lot of you could probably do that in your head because they both had the same time together. But what if we change the problem? So now it takes Ryan 20 minutes to do the job. The setup's exactly the same, except Ryan's time changes to 20. Crystal still takes 10 minutes, and we still want them together to complete one entire job. So here my least common denominator is going to be 20 because both 20 and 10 are divisible by 20, or divisible, divided by quit. Divisible by 10, I can reduce them both. So all 3 terms get multiplied by 20. The first one, the 20s cancel, leaving you with t. On the second one, 20 and 10 reduce to 2 over 1. So now I have 2 times t, which is 2t. And it's going to equal 1 times 20, which is 20. If it's possible. You can't, like I could have multiplied 20 times t and then divided by 10 and get the same answer. So now I have t plus 2t, which is 3t equals 20. Divide both sides by 3, and the time is approximately 6.67 minutes. Keep in mind, if you would have solved this problem and got an answer of like 12, I know that's wrong because Crystal can do it by herself in 10 minutes. So your time together should be faster than one individual could do it on their own. So in the past, I've had students give me some crazy answers. I'm like, well, Crystal can do it in 10 minutes. If Ryan's helping, shouldn't they be faster? Absolutely. All right, question on the back. See if you can set up this question. So if Miss Carolyn can grade papers alone in 30 minutes and Miss Miriam can grade them alone in 45 minutes, how long will it take for them to grade the papers if they work together? So the together time, which is just t, we don't know that, that's what we're trying to find, divided by one of the individual's time plus the together time divided by the other individual's time should equal 1. So hopefully you set up your problem t divided by 30 plus t divided by 45 equals 1. If you switch the 30 and the 40, that's okay, as long as you have one of each. So now I get to decide my least common denominator. So I need the smallest number that's divisible by 30 and 45. In this case, 90 is the smallest number that's divisible by 30 and 45. There is a way that some students use, you just multiply the denominators together. You can do that, it just gives you bigger numbers. Your answer will end up the same in the end, you just have bigger numbers along the way. That's fine with me as well. For this one, we're just gonna use 90, so we're gonna multiply every single term by 90. Then I'm gonna go ahead and reduce 90 divided by 30 is 3, so 3t plus, if I take 90t divided by 45, I get 2t, and it's going to equal 1 times 90, which is 90. So now you have 5t equals 90. Divide both sides by 5, and the time would be 18 minutes. Double check. Remember, Caroline can do it in 30, Miriam's 45. The time together is less than both of them doing it individually, so we're probably good. If we look at the next question, if Miss Caroline can grade 25 papers in 30 minutes and Miriam can grade the same amount in 45 minutes, how long will it take them to grade the papers if they work together? This is the exact same problem as the one above it. The only thing they've added is that they've told you how many papers they're grading and the first one didn't. So don't worry about that one. It's just the same as the one above it. It would take them 18 minutes because it's the exact same scenario above. The first one just says they can grade a stack of papers. The other one says they're grading 25 papers. For this next one, we've changed it up a little bit. We've told you, excuse me, if Taylor and Aspen work together, they can clean a house in 2.4 hours. working together. So that number actually this time is going to go on top of both fractions. So 2.4 goes on top. It says it takes Taylor 4 hours to do it alone. So I'm going to put a 4 here. How long does it take Aspen to do it alone? We do not know Aspen's alone time. You can put any letter there you want. I'm going to put an A for Aspen. So now I need to find my least common denominator. One denominator has a 4 in it, the other one has an A in it. In this case, my least common denominator is going to be 4A. I'm going to multiply all 3 terms by 4A. If I've done this correctly, something should cancel and I should eliminate all my denominators. So here the 4's cancel on the first term. So 2.4 times A, 2.4A. Plus, for my second term, I have 2.4 times 4A divided by A. Well, my A's are going to cancel, leaving me with 2.4 times 4, which is 9.6. And then my last term, 1 times 4A. 1 times 4 is 4. Bring the A down. So now I just have a basic algebra problem to solve. I need to combine like terms. I've got to move. I would move the 2.4A by subtracting it to get 9.6 equals 1.6A. Beside it, divide both sides by 1.6. So A equals 6. So Aspen if Aspen was doing it by themselves, it would take them 6 hours. So we're working with problems really similar to what we did earlier. You got to find that common denominator, multiply all 3 terms by it. And then just simplify what you've got. For these, you're just going to end up with a linear equation to solve. Get your variables on one side, constants on the other. For the last one, Lena's draining her swimming pool. One hose can drain in 9 hours alone. When she hooked up a second hose, together, they drained the pool in 2.25 hours. How long would it take the second hose alone? So we know we're figuring out the second hose's time alone. So that's going to be one of the denominators. I'm going to use H for hose. It doesn't matter what letter you pick. I know one hose can drain it by itself in 9 hours, and together it took them 2.25. So the together time gets used twice in both the tops. What's your least common denominator? Yep. So 9H or 9X or whatever you use for that second hose. Multiply every single term by 9H. If we've done this correctly, the denominator should cancel out on every single term. So 2.25 times 9H divided by 9, the 9's cancel, leaving you with 2.25H. For the second one, the H's cancel, leaving you with 9 times 2.25, which is 20.25. And then the last one, you don't have a fraction, you're just going to multiply 1 times 9H, which is 9H. Again, if you have X, that's fine. I would subtract 2.25H from both sides. leaving me 20.25 equals 6.75 H. Beside it divided, I'm going to divide both sides by 6.75 to get H equals 3 hours. So that second hose, if I was only draining the pool with the second hose, it would take 3 hours by itself.